Okay. Today we'll cover a topic that is network architecture. In fact, every system has architecture. Architecture is actually a high-level picture or big picture, or you can say bird's eye view. But the word architecture is mainly associated with building, construction. Okay, and architecture is a branch of study in that area. Okay, we are not talking about that. We are just talking about architecture means here network architecture. Network architecture means high level view of our network. Okay. As a network engineer, we should know the big picture of a network, how they are connected, how network devices are connected, how their physical connections are there and logical connections are also there. There is also different protocols. Okay. Let's look at the definition provided in Cisco website. Cisco website says network architecture refers to the way network devices and services are structured to serve the connectivity needs of client devices. Okay. But Wikipedia definition is more elaborate and it's, I think, covered most things. Network architecture is the design of a network, of a computer network. It is a framework for the specification of network physical components, their functional organization, configuration, its operational principles and procedures, as well as communication protocols used. Okay. In a simple way, you can remember network architecture is high-level definition. In professional field, we use two terms, HLD and LLD. HLD means high-level design. LLD is low-level design. HLD means high-level connectivity. That means where you just say there will be a router or several routers, and there are switches, there are different connectivities, there is Wi-Fi connection, this type of presentation. Okay, and low level is actually more detailed. LLD contains the actual network diagram and connecting interface number, IP address, etc. Okay. So we need to know the big picture of network for troubleshooting purposes or understanding of our network. So when you need the architecture, although when you join a organization, you will not architect the network, you just work day-to-day activities, but to perform day-to-day activities, you have to know the architecture. If you understand the architecture, then everything will be easier to you. That is why architecture is very important. So today we will show different types of network architecture. LAN, WLAN, WAN, and cloud also, okay, or virtualized environment. Because nowadays virtual technologies and cloud computing are becoming more popular, and virtualization technologies are everywhere, and cloud is also everywhere. So different organizations are using that technology. Okay, we have already covered many architecture, but I repeat it here for your understanding. Okay, at first, look at simple architecture of network. Okay, simple architecture. Okay. Simple architecture are of SOHO. SOHO is small office, home office, LAN. Okay. We have a LAN connection for our home, and also if you are working in a small business or your own business, which is very small at the beginning, in that case, you will establish a very simple network or LAN. It is like very simple. We are familiar with this type of network. We take ISP connectivity to a modem. If we take connection with cable modem or telephone line or direct LAN cable to our router, it's also possible, or fiber cable to a fiber device. And then we may have a firewall, but we rarely use firewall, but we should use a firewall device so that we can protect our network. And then we have a router, and router is connected to a smart switch, which provides connection for some computers for wide connection. Okay. And we also have different devices that is wireless capability, and we use just wireless access point connected to the switch. Okay, this is a very simple design. Okay. Okay. Do you have any question? Okay. I hope it is very pretty straightforward and you understand. Okay. Then we will look at our enterprise level networking. Okay. If you are working in a medium-sized organization, say you have 300 to 500 end users. In that case, the network design would be two-tier. That means it is two levels. Okay. What are the levels? Levels are distribution layer and access layer. What is access layer? Access layer are a group of switches usually, which are directly connected to our host or computers. Okay. And distribution layer is not directly connected to computers. They are working as a distribution on network traffic to the access layer switches, or it is also known as aggregation switch. Aggregation means access layers has different traffic coming to the distribution or aggregation switch, and it aggregates and passes the traffic to the outside LAN 1 or internet connectivity R1 and R2 router are connected to wide area network or IS. Okay. So these two-layer distribution can be used. Distribution switches are housed at the central location, and access switches are different installed at different areas. Okay, let's see a more realistic picture. Okay, look, two-tier campus design. In this, imagine you or the organization has three buildings. Okay, building one, building two, and building three. And in building one, uh, there is two distribution tools. In building two, two distribution tools. And in building three, you have also two distribution tools. And two distribution switch has also access switches, um, which are used to directly connect to a computer. Okay, and distribution switches are also connected with other distribution switches in a mesh connection. It is mesh. Mesh means every point is connected to every point. Okay, but it is not practical network. Providing mesh connections are not feasible in practice. But what is with the more realistic picture? Okay, but the more realistic picture would be okay, providing some redundant connection, but not connecting to all points, all switches. Okay. So CTR, we look at CTR architecture. CTR architecture has three layers. Access layer and distribution layer is also there, but there is a core layer. It is also known as backbone layer. Okay, backbone layer. Okay, backbone layer has the capability of routing or sometimes. Okay, in the previous design, we have another thing. Maybe in distribution layer, we can put layer 3 switches sometimes. Okay, so that we can configure gateway. Okay, different computers have gateway. Gateway can be configured in distribution on layer switch, not in the access switch. Okay, but some people may also configure gateway in the router. Okay, but in 3-tier, we usually configure gateway at core layer or backbone layer, or you can use it in distribution layer. Okay, gateway can be in distribution layer, and these are connected to access layer. Okay, in large enterprise, where there are many users in the case, you can install backbone or core layer switch in a central location, and then distribution layer or switches can be installed on different buildings. That is also the central location of that building or location, and then access switches are installed at different areas near to the users. Okay. And one practical, almost practical network will be like this. There is two core network, four switches. Four switches. Why four switches? Because they can work as redundant for each other. If one switch is faulty or down some reason, then another one can carry all the traffic. Okay, your network will be more resilient and fault tolerant. Okay, that is why there is also two distribution switches, and every access switch and every distribution switch and every port switch has redundant connection. For distribution and access, there are two connections, at least from two switches, so that if one connection is disconnected, another one will work. Normally, one link will be blocked by spanning tree protocol, so that there will be no loop. Okay, this type of network utilizes a spanning tree because without a spanning tree, there will be loop, switching loop, which will make the network unusable. Okay. So a spanning tree in a protocol is working in this network, and redundant links will be blocked. Only one link will kill traffic. Okay. So this type of network are used in three-tier design. Okay, do you have any question, or can you understand this diagram, or do you have any? Maybe no. Oh, okay. Okay. Let's. Okay, I already mentioned or discussed the power of our Ethernet. Power of our Ethernet is just transferring power to device of our Ethernet cable, copper cable. Okay. It has great impact on your network design or network architecture. When you are architecting the network, you have to also plan for power over Ethernet. You may have some devices like IP telephone or Wi-Fi access point or IoT devices that can be installed outside the building or in the garden or on the roof even, okay, or outside the building walls. So where there is no power available, you can provide or install this type of devices without installing AC power outlet, because installing AC power outlet outside the building is difficult because water will cause a problem if electric power cables are exposed to rainwater. So in that case, we can provide some IoT devices or cameras power over Ethernet cables. So when you are architecting or designing a network, you have to plan for power over Ethernet switches or number of ports. Okay, so it is important in this regard. Okay, and yes, actually, in the last session, we also discussed about wireless LAN architecture, but I am repeating along with this other types of network architecture. We discussed wireless LAN autonomous access point, where each access points are working independently, and you can also send management traffic in a VLAN, and you can use different VLANs for different service that identified as IDs, and you will connect your access point to switch in trunk mode if you are sending multiple VLANs traffic. Okay. Then we discuss cloud-based controller. A controller are based controller based Wi-Fi network, which is then normally you will install a WLAN controller or WLC in a central location, which will control all the lightweight access points that are installed across different areas of your office or your campus. Okay, and we also told about cloud-based controller, and the controller can and in cloud and over internet connectivity, it can manage your APs in your organization. So you don't need to install a WLC in your premises. Okay. So these are Wi-Fi architecture. These are broadly architecture, Wi-Fi architecture. Then we also discussed one architecture in the last session, but I will discuss in more detail today. We talked that we can provide wide area network connection using different technologies. Wide area network connections are required when you have offices in different locations in a large geographic area. So you have to choose the technology which can provide connectivity between your office branch. Okay, there are some organizations who have as office locations across the country or across a large area, or even in many different countries. So they need wide area connections. So, so Metro Ethernet is one way of providing connectivity between those offices. It can provide layer 2 connection. That means the whole Metro Ethernet will appear to network as a switch, as if you are connecting to a switch. Okay, Metro Ethernet is a variety of one services and layer 2 service the work provider forwards Ethernet frame. Okay, it will provide Ethernet frame, and like this, Metro Ethernet is this cloud is Metro Ethernet. Okay, this cloud is Metro Ethernet, and your trans network has 3 routers: R1, R2, R3. Okay, maybe R1 is at your headquarters, and R2 and R3 are at different locations. So they are connected to a network that is called Metro Ethernet Service Providers Network, and it is like you are connected to a switch, and they are connection between a service provider switch are maintained or managed by service provider. You have nothing to do with that. You will get just connectivity between your router 1, router 2, and router 3. Okay. So you will just connect your router to the nearest switch or router of service provider. Okay, there are different types of Metro Ethernet connectivity. It can provide point-to-point connection. And imagine you have 2 offices only in 2 different locations. In that case, you need only point-to-point, or you have a central location of it, and you have many offices across country. In that case, you may need mesh-like connectivity, or you can go for hub and spoke. Hub and spoke means all central, all branch offices will connect to central location, and if they want to connect to another branch office, then it will go to central office. So it is a hub and a spoke. But if it is a full mesh, in that case, any branch can connect to any branch or headquarters without any dependence to another branch. Okay, and directly connect in that case. So there are so if you get a glimpse of this type of connectivity, then point to point is like this. You have router 1 and router 2. Router 1 is at one location, router 2 is another location. So Metro Ethernet is just providing you point-to-point connection. And then in case of mesh, say you have 4 branches, R1, R2, R3, R4, and then they can provide mesh connectivity. So any branch can connect to any branch without dependency on any dependency on any other branch. Okay. Hub and spoke is like this. Just hub is the central, say R1, and R2, R3, R4. If R2 want to connect to R3 or R4, it must go through R1. Okay, this is the dependency. If R1 is down, in that case, R2, R3, R4 will not be able to communicate with each other. This is the drawback of hub and spoke. But it may be simpler configuration. But a mesh-like configuration has benefits of any one connect to anyone, but it may be costly and configuration will be more complex. So we have another one connectivity option, that is MPLS, multi-protocol level switching. So Metro Ethernet is not that popular in our country, as far as I know, but MPLS is a very popular technology, because different large internet service providers and mobile telephone operators have a nationwide MPLS network. In fact, most mobile phone operators across the world build a large MPLS network across the country where their base stations or in their network coverage. Okay, so they build a network which is called MPLS. It is actually it can be built by a operator, or sometimes MPLS network from some other provider. Okay. So why it is called MPLS, multi-protocol level switching? Multi-protocol means we can carry multiple protocols, IP version 4, IP version 6, and other protocols. Say layer 2 protocol can be transferred over MPLS network. So it is an interesting network. It uses level switching instead of IP based routing. Okay. Also, although IP routing is the underlying technology of this network, So, what are the benefits of this network? It is highly reliable because MPLS service providers are reliable in most cases, at least in our country. It is very high, it is highly reliable. All MPLS networks are built by mobile operators and ISPs. And one drawback is costly. Okay, you have to purchase the bandwidth, and they will provide you service level agreement, and it's okay. So, what is the scenario of this type of connectivity? Say you have 4 branch offices, R1, R2, R3, R4, and MPLS network there, and you will connect to this through this network. Connection will be like you will just connect your router to the nearest router of the service provider, which is the provider edge router, and your edge router is customer edge router. So you have a border router or edge router of your network, which you will use to connect to provider edge router or nearest POP. We call it POP, point of presence. Okay. So you will just connect. Okay, and connectivity between providers router are service providers. So here another additional thing is that you will connect to your provider as or point of presence router of service provider. Okay, but what if your router is far away from service provider's point of presence? So say your office is place, but their POP nearest POP is say 5 kilometers, okay, or 3 kilometers. So in that case, you have to install another connectivity. So one option could be cable TV operator's cable connection. Okay, you will install a modem at your site and connect to your local cable TV service provider's cable, and about their network, you reach to the point of presence of service provider, where you install another modem and you connect there. And there are another option. You can also use Metro Ethernet locally to reach MPLS. You can use TDM based different connectivity, that can be optical connection, and another connection could be point-to-point radio. Okay, you install a radio on your rooftop, and another rooftop of another radio at the rooftop of point of presence of service provider. Okay, you can provide connection between that, or you can use 4G or 5G network. If you have 4G or 5G coverage, 4G, 5G has huge bandwidth. Routers have a different slot for SIM card connections. Different router models can use, or you can use separate modem, and then from that modem you will connect LAN connections for the router. So in that way, you can also install connectivity between your local router to point of presence router of service provider. Okay, and then as MPLS will cover, say your office is 200 or 300 kilometers away. So locally you have one type of connections, and then for large for larger distance you use MPLS. Okay. But what MPLS or Metro Ethernet are very costly. So internet connectivity may be available to your location, so you can use internet VPN, which can be GRE tunnel. GRE tunnel is not secure because they don't provide any confidentiality, integrity, or authentication facility. Okay. To configure security, you can use IPsec tunnel, security tunnel. Okay. So look at this picture. You have a branch of it, you have central headquarters. So you are just sending traffic using VPN. VPN is tunneling. Why it is tunneling? Your entire IP packet will be repackaged in another packet. Okay. So if any intruder or someone intercept your traffic, apparently they will see different traffic based on source and destination. But if they analyze packet more deeply, in that case, they will see your original traffic if encryption is not. However, if you use encryption with a strong algorithm and strong encryption key, in that case, no one will be able to see the traffic. Okay, they will see the source and destination only, not the actual traffic. So tunnels are like this. Say you have router 1, router 2, router 3, router 4 at different locations. You are creating tunnels. So you can use GRE tunnel with IPsec. Okay. GRE tunnel with IPsec, you can install a site-to-site VPN with security. Okay. IPsec tunnel is not covered in CCNA course, but GRE tunnel is in detail. Okay. And there are other options of wide area network connection, DSL, digital subscriber line. In old days, or maybe 2 decades ago, or 2 decades, or 15 to 20 years ago, I would say, the telephones, landline phones are popular. So people use those telephone lines for internet connection. That was popular at that time because there was no internet infrastructure. And then we can use cable, we can use 4G, 5G network, even 3G network also. But 3G is slower than 4G, and fiber Ethernet, dark fiber is dedicated fiber that has no signal initially. You will just lease them and send transmit and receive signal about this server. Okay. Okay. And radio link, I will discuss, and satellite also. In case of remote islands in Arjun, you have to install a network connection, and for a remote island where higher level installation is not possible, radio link is not also possible because of distance. Say you have an island which is say 50 kilometer or 100 kilometer away from your mainland. So how can you install a connection? Radio link is not possible for that distance. The fiber is not possible in the sea or river. Okay. So you have one option. In that case, you will use satellite. Then let's show you how they are practiced. So in old days, public switch telephone (PSTN) network were used to voice communication. And okay, so later when internet developed, people developed a mechanism to deliver internet over this telephone line. So they use a DSLM system in the telephone operator's office, and they use different DSL modem at your office or home. Okay, and then DSL modem provide Ethernet connection to your router, and from the router you will take your connection to our computer or laptop. Okay. It was very old technique. Maybe in some region of the world, still people are using this technology, but over time it will phase out. Okay. At least in our country, I don't know who are using this. Maybe it is not used that much. Okay. But another technique for internet connection, people had cable TV connection using coaxial cable. Okay. So it was since more than 2 decades or more, people 3 decades, I would say, people are using cable TV connection. So they have infrastructure. So for internet connections, they have developed also a technique to deliver over this cable and using a cable modem similar to DSL line. Okay, another technique is radio link. They install a radio at your location, and there is another at the location where radio link internet service is provided. So you have point-to-point connection. You need a line of sight connection. It is one technique. Okay, radio link normally connects your network at layer. Okay. And radio link can be point to multipoint. That means there is one central transmission reception device, receiving device, and there are multiple receiving, transmitting device at customer premises. Okay, it is radio link is very popular in many parts of the world, including here in our country. Okay. And 3G, 4G, 5G network is very popular, although 5G is not installed in many parts here, it's not available. We have 3G and 4G network. With 3G and 4G, most people take internet connections at individual level for their personal device connectivity. But for enterprise level, it is not that much popular because lack of bandwidth. But in future, when 4G will be more developed and 5G will be available, many organizations will be able to install modem and provide connection to their local router, and from local router they will use connectivity for their LAN. Okay, it is actually evolving. In future, it may be more popular, I imagine. Okay. Then what I already discussed, if you have a very remote site, especially in island or in a very another scenario can be in a very distance area like hill tracks, for example. In some regions there is desert. Okay, in a desert, maybe thousands of kilometers. Okay, there is no feasible way of connection. In that case, you can use satellite for hilly region, say in Himalayas, for example, in this area. So if you want to connect from some hill, in that case, satellite is the option. Okay. Although those were discussed earlier, I repeated for your understanding or more clarity. Okay. Today, two new technologies discussed. One is virtualization and virtual network. Up until now, we have discussed only physical devices, physical appliances, which you can see, touch, directly configure. But over the years, there is okay. You have raised okay. Do you have any question or anything? Okay. Okay, can you hear me?
Yes, sir.
Okay, but someone raised hand in the meeting. Maybe they raised hand. Do you have any question or anything, or just mistakenly raised hand? I don't know. Okay, let's continue. Do you have any experience with virtualization or virtual computer? Anyone?
Yes, we have done it in cloud.
Yeah.
Virtualization.
But you work in cloud. Which cloud? Which cloud?
In AWS.
AWS. Okay. You can use AWS, Azure, Microsoft Azure. and Google Cloud Platform, DigitalOcean, Alibaba, IBM Cloud, Oracle Cloud, and so on. Okay. However, okay, virtualization is there, but you used virtualization using cloud, but did you directly use virtualization?
Yes, sir. We have raised some
Yeah, which
kind
one?
of virtualization.
Which one? Is it Hyper-V or VMware or VirtualBox? Gen, which one?
VirtualBox. VirtualBox is the one.
VirtualBox. Okay, great. If you are using Windows operating system on your computer, Hyper-V is there. Okay, you can use Hyper-V easily, and you can install VMware workstation. You can use VirtualBox, and okay, then you can easily use them. So when you are creating virtual machine, you have to create virtual network also, because virtual machines, virtual servers are connected to virtual network, and virtual network is connected to your physical network. Okay, that is why I am talking about virtualization. Virtualization is very common. Look in this picture, you are seeing that is server. It is a Hewlett Packard Enterprise HP server. Okay, this server has compute. That means it has computing power, and it has memory RAM, and it has storage, SSD or SSD. Okay, and it has NIC cards, network connectivity for network connection. Okay, so there are four areas of physical network, but virtualization is developed. So these days, we do not use separate servers for different activities. Okay, in around 10 years ago, for example, we use separate servers, physical servers for different services. Say we have web server, we are just installing a server, physical server for web server. We have another web server, we are installing another server. We have email server, we have another server, and FTP for another. So in this way, there are many servers in the rack. All are physical and separate for separate service. But now we don't do this. What we do, we buy a server, for example. Actually, one server is not possible because there should be redundancy. If one server fails, another server. So there is different clustering. But we have one cluster, or imagine just one server. And we have all these things: compute, storage, memory, network, 4 areas. Okay, and we install a hypervisor, a kind of operating system, and then what we do, and then we create virtual machines, different virtual machines. Say we need 10 servers. Okay, we just create 10 virtual servers or virtual machines and install the application on those virtual machines. So with one physical server, we get 10 machines, say, or more. Depends on your requirement, your capacity of the physical hardware. Because if you don't have enough compute, memory, storage, or network capacity, you will not be able to create so many machines. Okay, there is constraint. Okay, so what are the virtualization technologies we use? We use VMware, we use Microsoft Hyper-V, and Citrix Zen server. We use recent VMware. Okay. We can use free open source open source Linux KVM or Red Hat KVM. Okay. These are popular virtualization technologies. There are other virtualization technologies that can be used by different cloud providers. Say VMware can be used different clouds, or different cloud providers may have their own virtualization technology. It is called hypervisor technology. Okay. So whenever you are talking about virtual machines or virtualization, you have to talk virtual network. So to connect virtual machines, you need a virtual network. What is the architecture of this type of technology? Look, this car is a server. It is a physical server, server hardware, host. We call it host. Okay. And there is hypervisor. Which hypervisor? VMware, Microsoft, Hyper-V, Zen server, Red Hat KVM. Okay, whatever. So then you can create virtual machines. Okay, there are 4 virtual machines. Virtual machines have also OS, operating system, and applications are installed on that operating system. Okay. So now comes to network. So how you can connect these virtual machines? Virtual machines have same network configuration as physical network. Okay. So you just connect to virtual switch. Okay. This switch is totally software based, resides in your host machine, in your hypervisor. It is virtual, totally virtual, software based. And this software based network, you have a switch, we call it virtual switch or V switch, and it has network interface card and VNIC. We call it VNIC as it is virtual VNIC. And these VNICs are connected to virtual switch, and this virtual switch is connected to physical switch in trunk mode. If you use multiple VLANs, say your virtual machines are in different VLANs. In that case, you will connect trunk interface. Okay, in between there is another issue, it is physical mix. So virtual switch is actually connected to physical switch of the server, because server is some network interface card, one or more. Okay, so your switch is connected to your virtual switch is actually based on this NIC cards, physical NIC, and these NIC cards provide LAN connections to your physical switch. Okay, what will be the connection type? You can use access port connection for the switch. If you are using only one user, so no problem in this. What if you are using, say, there are 20 virtual machines in the host and 20 VLANs, sorry, 20 virtual machines or VMs belongs to different different VLANs. Okay, virtual machines belong to different VLANs. So in that case, your connectivity will be trunk, allowing all the relevant VLAN IDs. Okay. Okay, it is clear to you or any question?
You get it, sir.
Clear to you, okay?
Yes, sir.
Okay, great. So why I somehow repeated this slide is okay. So it is very important because wherever you go to work nowadays, you will encounter virtualization and virtual networking. So that is why these virtualization technologies are included in CCNA. When we started CCNA long ago, so virtualization, cloud, this kind of technologies are not there because those technologies are not popular, that much popular. Okay, as it is very common. From the first day of your job, maybe you will face this type of systems. Okay. Okay, then cloud computing. Okay, actually, cloud computing is based on actually virtualization. Without virtualization technology, cloud computing would not develop. Okay. So if you understand virtualization or virtual machines, so you will work similar things in the cloud. But cloud has one difference, one major difference. Virtualization technologies is on premises. You have a data center, you have servers, you have configured virtualization technologies and virtual networking systems are also configured there. But with cloud computing, you don't have any computers on your premises or in your site. Okay, you will not see any computer. You don't need to install or buy any computer or networking device. Okay, you just need a network connectivity to reach internet so that you can log into service provider portal. Okay, you will get virtual machines, you will get virtual network over there. So it is the development. So what are the characteristics of virtual computing? Virtual computing has some features: on-demand self-service. That means when you need a server, you will buy a virtual machine from service provider. Okay. Self-service means you can provision. So you need virtual machine, or you need to install a web server. So you log into Amazon Web Service. Then you give payment. Actually, the postpaid, not prepaid option is also as well. And then you pay with your credit card. You don't need to talk or call anyone of Amazon or Azure, and then you will create a VM yourself. Okay, using their virtualization technology, you will just create a machine, configure and install operating system, Windows 10, Linux, or anything else, and then you will install your platform or run your codes, whatever are your coding language. Okay, whether it is PHP, whether it's .NET, whether you are using different framework for web. Okay, just run on them. Your website will be available for all. Okay. So it is on demand and self-service. And broadband network access, broad network access, not broadband, broad network access means you can connect anywhere. Okay, you are sitting with your laptop at a coffee house or a shop. You are just configuring your server. You are at your home. Okay, you can configure your server from there, no problem. So there is no constraint. Just go to office data center. There is no constraint. Okay. And resource pooling. Resource pooling means cloud computing service providers do not buy computers or servers or networking routers for you. Okay, they buy for large number of people. Okay, for their clients. When you use some portion of those hardware, and when you release, say you decided that I will not run the server anymore, I will release all the resources and I will not be charged anymore. Okay, so in that case, you are releasing your resources, compute, storage, memory. Say you book 2 virtual CPU and 4 GB of RAM, say storage, say 50 GB storage, and network connectivity, IP address. So all this you are releasing because you are not interested for this cloud. Maybe switch to another cloud provider, or you are not interested in this. So your resource will be released and used by someone else. Okay, so it is pooling. And rapid elasticity is also covered. Rapid elasticity, you can create a virtual machine, and somehow you you installed a web server, e-commerce web server. Say you are starting a business. Okay, but after some time you found that your e-commerce site is very popular and your business is growing, so more people are hitting your website. So you need more compute power, storage, and RAM. Okay, so you can increase it automatically even. Okay, you can configure automatic configuration, then it will automatically increase the capacity of your server, or you can manually configure your server capacity. So it is rapid elasticity, or you have found that your e-commerce is very popular, but many people hit at the evening. But at night, there is less traffic. So you don't want to give charge to service provider. In that case, you configured automatic elasticity, So at night, server's capacity will be reduced. So your billing amount will be less. Okay. And measured service, it is measured service in this way. It has, we use different utility services at our home or office. Say, what are the utility bills? Electricity, gas, water supply are common utilities at our facility, different facilities. So electricity, what about electricity bill? You have to pay as you use. Okay, that means the more you use, the more the higher your bill will be. Okay, and this goes to water, although not everywhere. This can go for gas supply also. Okay, if it is metered. Metered means you will pay as you go. So for cloud computing, you have to pay as you go. The more RAM you are using, the higher your bill will be. Okay, but if it is your on-premises network, you have purchased a server with the RAM, with storage, but it is fixed. Your money is spent for this. Okay, whether you are using this or not, you have paid it. Okay, so it is not in that case, that is not metered. That is fixed amount you have spent on a server or a router or switch, whether you are using or not. It is your money spent. But for cloud computing, it is not the case, and you pay only as you go or use. Okay, this is another benefit. Or another thing is that if you buy different servers for some reason, your business is not successful. Maybe you are leaving your business. What will do your servers or things you will sell, but the cost will be very low because products has very low price. So, but in case of cloud computing, this type of risk is not there. If you don't need, leave deprovisioning your service. No problem. Okay, how we cloud computing architecture is like this. There is data centers, servers, switches, routers. Are there data centers of service provider, Amazon Web Services, Microsoft Azure, Google Cloud Platform, and other vendors have their data center, very large data centers, and they have configured everything for you. They have given a portal for you for self-service, on-demand self-service. So you will sign up to those portals, and you will create different virtualization technologies in the portal, and you will have all the computing capability, networking capability, of course. So this is very sorry. So there is two options: GUI and API. GUI means graphical user interface, just a web page. You are clicking everything, and you are configuring network, you are configuring virtual machine, everything. But you have another option, API. If you are using different types of software, for example, for large network management, you will use scripts, for example. In that case, you will use API, application programming interface, for this type of configuration. say if you are configuring one or two virtual machines and network, and you can use GUI and by clicking your mouse, okay, part, what would happen if you have to configure the 200 servers for some organization or different networking components. So in that case, by clicking one by one, it will not be easy for you. What you will do, you will create scripts, and with this script, you will configure in this script everything. Configure means you will put different values, change different values according to your requirement or environment, and then run those code on cloud shell, okay, in our command prompt, okay. You know, PowerShell or different Windows, in Windows and in Linux there is also command prompt, okay. So you will run those commands there, and your required virtual machines and networks will be configured accordingly, and you can verify later. Okay. So there are different types of cloud computing deployment models. The private cloud on premise. Private cloud means nowadays many organizations use own virtualization technologies, as I mentioned earlier, and they create their own cloud for their use. So they use their own cloud. Okay. So they have interface for creation or deletion of virtual machines and networking, and they use it for their own purpose. Okay, they will not rent it to others. Okay, that is why it is called private cloud. And they have public cloud, which is for general people. Okay, say AWS, Azure, or GCP, Digital Ocean, Alibaba, IBM, Oracle. They have deployed cloud platform for anyone. Okay, that is why it is called public. And then we can have community cloud. Community cloud means a group of people or a group of organizations. Say there are 5 organizations come together to build a cloud, and they will use it. Okay, that is what is community cloud. And there are hybrid. Hybrid can be you have a data center, you have cloud also. Okay, so when you are using in combination, and then it is called hybrid cloud, and then you can install multi-cloud. Multi-cloud is using several clouds. Some organizations use several clouds. They use Azure and then use AWS and GCP for different services. Okay, maybe they feel that they have more suitable services in different platform. Okay, they use them in combination, and okay, so that is why it's called multi-cloud. So okay, it is also repeated. Let's delete one. And then we have different service models. Okay. In cloud architecture, there are different service models. Infrastructure as a service, it is written as IaaS and AAR in lowercase. Okay. And provide why it is called infrastructure service? Because they provide compute, memory, storage, and network, and you need to install operating systems and your application and data. And we have platform as a service, PaaS, provides environment to run your code. Say you have you develop codes for your application. Okay. So in on-premises case, what do you do? You have to prepare your server. You have to configure all the runtime environments, and then you run your code. So there are different activities. Okay. But with PaaS, you don't need to think about operating system or anything. Maybe you are running .NET code, for example. Okay. So you take .NET environment from a service provider like Azure, AWS, or any other platform, any other cloud. And then you run the code on that platform. So it is easier for it. And then we have software as service model, SaaS model. It is very common, and we use it on a day-to-day basis. So we use Gmail, we use Outlook, we use Dropbox, okay, Google Drive, for example, or anything we use. Say WhatsApp, we are using Facebook, all our software as service. Okay, everything is in the cloud. So there are 3 service models, but what is the benefits or drawbacks with each model? Okay, for IaaS, the main benefit is that you have control on your server, more control. Okay, you can install your own operating system, can change or customize your operating system as per your requirement. You can configure security features. Okay, but with PaaS, you don't have option to choose operating system or different security features. With SaaS, you don't have to install operating system. You just use their operating system, their application. Okay, their application. And these are the differences. But it is said that SaaS service security is the responsibility of the service provider, and PaaS has operating systems and upgrades are also their responsibility, not you. Okay. But in case of infrastructure service, you have to configure security, and software upgrade is also needed. So in cloud computing, networking is totally virtual in the cloud. Okay. Say in AWS, for example, we have a VPC, virtual private cloud. So within a Amazon web service. It is a large system, imagine. In that system, you have also a smaller system, virtual system that is your own. Okay. So this is the diagram. So in this diagram, you can see that you are using a VPC, which is your own virtual private cloud, and one virtual machine is there. So you can think that it is your virtual data center. Okay. And it is connected to a router, virtual router, and this virtual router is also connected to internet gateway. You can imagine also a router. And there are other services outside this. So here, if you have more than one virtual machines or other different networking or computing devices, how you will manage network? Totally virtual network. Okay, that is called virtual network. Okay, it has similarity to virtual networks as we discussed with regard to VMware, Hyper-V, etc. Okay, similar, almost similar. Okay, all are virtual. Okay, can you understand? Okay, do you have any question or anything? What about Mvico? Can you hear?
Sir, Dico is admitted in hospital. He has some operation in his throat. He just was your class, but he didn't speak anything.
Okay, I understand. Thank you for information. Okay, what about you? Can you understand things?
Yes, sir. Sir, cloud computing, we read in before. That's why your lecture is somehow understandable.
Okay, great. Okay, in that case, it is a repetition, no problem. Okay, it will be good, I think. Okay. But cloud computing is very common nowadays. So you should focus on this computing. Okay. Okay, let's proceed. Okay, we are just talking about how you will provide connectivity between those virtual machines inside your cloud. But what about your devices, your users' devices? Connect to those virtual machines, virtual servers. Okay. One way is public internet. You are using internet to connect to public cloud system. Okay. So you are connecting to Google Drive. Google Drive, it is also in cloud. You are using Microsoft 365, which is email solution. Over internet, it is one option. Okay. So you can use internet for this connection, this type of connectivity. Why you are connecting? Just to use cloud service. Okay. So using internet is straightforward and easy option and cheap option also. But drawback is that internet sometimes unstable, may not provide you quality of service, and security is also concerned. Sometimes if your data are not encrypted, in that case, someone in the internet can intercept your traffic and your data will be breached, okay, or hacking possibilities there. So another option can be private wide area network, and Vpn tunnel is another option of our internet. Okay, these two options are important to understand. So you can establish a VPN tunnel of our internet using your on-premises router. Okay, you have router in your organization or your enterprise. You can use this router or firewall at your end, and in the virtual network or in the virtual network or in the cloud, there are also virtual routers or firewalls or VPN devices. You can establish connection between them. Okay. What type of connection? It is VPN tunnel. So if you establish VPN tunnel, this kind of, then your traffic will be encrypted. Your traffic will be protected from unauthorized persons or hackers. Okay. So for security purposes, you can use this. But still, you have one problem. Internet may be unstable. Internet may be disconnected for some reason, and you lose connectivity to your cloud service, where your mail server or web server are hosted. So, so it is a drawback, but it is cheap still. Like plain internet, it is still cheaper solution, and you can configure it from anywhere. But what about private one, wide area network? So in some countries like USA, say Canada, or say Europe, there are data centers of Amazon or Azure, okay, or Google. They have their cloud data center. But in Asia, there are also data centers in India, Singapore. Okay. So some organization may be near or at some considerable distances of those from those data centers, so they can directly connect to those data centers with their private one. Private one can be over third-party Mpls networks or Metro Ethernet that I discussed in the one architecture section. Okay. So with this type of connection, you can establish a very stable connection, and the quality of service will be better, and you can establish more secure connection also, and you have control over this network in the sense that you can change different bandwidth or quality. But one drawback is that they are costly, although they are used by rare organizations in some countries, but they are very costly. Okay, because you have to pay to third-party networks, Mpls network, for example. Okay. Okay, then we have other types of connectivity if you are using multiple cloud. Okay, say you have some services hosted at Google Cloud platform, then you have some services on Azure, and okay, in that case, you will establish different wide area network connections, which is private, quite private, with your network. Okay, and inter-cloud exchange is another concept, and some architecture, some one can build this type of network, but this is also very costly. Okay, then they also established private one with enterprises. Okay, so they can build different private one, and they are reliable and secure, but they are highly costly. Okay, just 1 minute. Okay, before this just that. Okay. So, do you have any questions or anything regarding anything architecture related? Okay. So, as a network engineer or network administrator, we have to understand all the types of architecture. And if you have the big picture of the network, in knowledge, in that case, it will be easier, easier to configure, maintain a network, and you will understand which device or which configuration is critical and very important for your system. Okay, so this is an important area. So what about other? What about Abdullah? Yeah.
Sir,
Abdul?
most
Yes,
of
sir.
the students are disconnected. Maybe electricity gone in IIT.
Yeah, we lost electricity. That's why most of them just
Oh.
disconnected.
Oh.
Yeah, they are still to join back.
Okay. Understand. Okay, they can go through the record. Okay. What about you, Abdullah? Do you have any question or anything, or everything clear?
No, it's okay. It's okay. It's pleasure.
Right. Okay. Actually, every architecture of this type of networks are covered in CCNA. It's great. So from the beginning, you will get the big picture of different types of network, networking. Okay, it's good. But when we studied CCNA first, we have only LAN and wide area network covered to limited extent. So VPNs are also discussed here, and other like cloud and virtualization. So, okay. Did anyone of you configured Hyper-V on your computer? No. Okay. If you have anything you can add, or we can discuss further, or we'll finish. Okay. 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 Go through this, everybody, and it will be good. Otherwise, if you don't have anything to discuss,
Sir, please, can you send us the slide?
yes.
Can you send us this slide?
Oh, okay. Okay.
Ngamira impala bana because this one is almost making it closer to my I don't know. Yeah, Capri, ngamira first time in a mountain.
Yeah. Any question? Okay. Is there any quiz? Okay, good question. Is there any quiz or exam after the end of this training? Okay, I thought to take a quiz, small quiz. Okay, yes, there is a plan. Okay. So at least go through all this material. And based on this, I will take a small test quiz. Of course, you know all the concepts, then you will be able to cover all these questions in the quiz. Okay.
Hello, sir.
Yes.
Yeah, sir, based on the documents that you just provided, please, can we have a common platform where we can access all these documents? Because there are some classes that others missed due to some conditions.
I hope you are getting all the records in the YouTube.
Yeah, that's right. That's
okay.
right. I mean, like that of the PDFs or slides.
Okay.
That
Okay. Today, I will create a location in the Google Drive. Okay. and then share. Okay, I will request our training coordinator, and I will provide the link, and he will share with you. Okay,
Okay, sir. Thank you, sir.
he will get. Okay, I hope I will do it today. Okay.
Sir, have you sent the slide?
No. Okay, sending.
Sir, when you think to do the quiz?
Sorry, quiz.
Yeah, when? Which day?
Okay, let's finish the course. It could be last day on. It could be on Saturday, I think. Okay. On Saturday, our finishing topic will be version 6, and after finishing, we can do it. Or another option could be, I don't know if there is another session with training coordinator for providing when you will be provided a training completion certificate. Okay, we can also do that on that day, but most probably Saturday. I will confirm you today, tomorrow, because we have also session on tomorrow. Okay, Thursday also we have session, so we'll discuss the beginning of the session. Okay.
Sir,
After
it's better
discuss-
to give us like some time so that we can also review what we studied before.
No, it will be actually based on everything, but it will be most general concepts of networking. Okay, may not be that detailed. Okay.
So like configuration, it is something like
No, configuration may not be there. Okay, may not be there because in a,
Is it like MCQ type or written?
no,
type?
MCQ, of course, MCQ. Okay, it would be like CCNA certification exam type question. Okay. Okay, just go through all the topics. I think it would be easier, would not be that much difficult. If you do not study anything, in that case, it would be difficult. Okay. Otherwise, it is not problem. Okay. Did you got the slide of today's?
Yes, sir. So will there be the report at the end of this certification, or only the quiz will be okay?
Sorry, can you repeat?
Yeah, I'm asking, when we finish the last day of the training, will there be a report, or the quiz will be okay for that?
Okay, as per our plan, we have 3 more sessions. One will be tomorrow, and we have also Friday and Saturday. That means we have 3 more sessions, and we will finish it by this Saturday, which is 30th October. Okay. And after that, a training coordinator told me that there will be a session for you where you will be provided your training completion certificate. Okay, but on which date I have to know, I have to discuss with him. Okay. Okay, I'll let you know tomorrow. Okay, and also provide all the resources. So whoever missed anything can get all the documents. Okay. Anything else or anything? Do you have anything? Discuss. And got the slide PDF?
Yes, sir.
Okay. Okay, if you don't have anything to discuss, then we can finish. And tomorrow we'll discuss different IP services. A topic that we have not discussed yet, that is quality of service. Okay, the different IP IP packets has different quality of service. So we'll cover this, and we'll also discuss Cisco switch and router or device management system. Okay, although we covered some thing device configuration, and we'll discuss in more details. An SNMP protocol is very important for device monitoring and management. Okay, we'll do some lab tomorrow, and we also cover another area that is different the services. Okay, but most of them are covered to some extent. But tomorrow we'll cover with some labs, and okay, you can study SNMP and the quality of service today, or go through it. Then it will be easier for you to understand when I discuss them. Mostly SNMP and quality of service, two areas you should go through. Okay, then we will discuss tomorrow and do some small labs in packet tracer. Okay. If you don't have anything to discuss, let's finish here. Okay. Okay. Do you have anything or finish? Okay. Maybe you don't have. Okay. Thank you. See you tomorrow. Okay. Thank you.